Hey everyone, are you tired of seeing amazing new AI models on Hugging Face only to find out you need a GPU to run them? What if I told you that you can run many of these massive models right on your normal computer using just your CPU? In this video, I'm going to show you the magic of quantization using a tool called LLAMA.cpp. Here is the repository of LLAMA.cpp. We are going to take a giant model, shrink it down, run it locally, and as a bonus, turn it into your personal free OpenAI endpoint. No premiums, no fees. Let's go. So here's the problem. You go to Hugging Face, you find an awesome model like something like this Quen 3 4 billion parameters. Yeah, it's a pretty large model, 8 GB. You check the files and wow, see these files. Uh, these are almost 10 files are there. Okay. The original FP16 or 16-bit precision model is over something like 16 GB or somewhat 8 GB here in our case. If you try to load this in your computer, for your computer it will just need a massive amount of video RAM or system RAM. This is where most people get stuck and just go back to paying for an API. But what if we could make the model smaller, not by removing parts, but by making each part less precise? This is called quantization. Here is a picture overview I am going to share with you. Uh, yeah, this picture depicts the quantization easily. Think of it like this. An FP16 model is like a high definition photo with millions of colors. Quantization is like converting it to a 4-bit int4 model. It's like a high quality GIF. Uh, the picture is almost identical, but the file size is dramatically smaller. And the king of quantization, the legendary open source project, which is nothing but a LLAMA.cpp. This project is the engine that made local LLMs possible for everyone. It's written in pure C++ and is incredibly fast even on regular CPUs. You can go through the documentation of this repository. They show you how to install this in your local computer. Now you'll probably heard of easy to use tools like LLAMA or LM Studio, and they're fantastic. They make this stuff one click. But here's the meme I want to show you. Yeah, here it is. Uh, these service providers are just the wrappers of Llama C++. Okay, what do you think they are built on? They are built on just uh, on top of this LLAMA.cpp. Okay, many of these great tools are essentially user-friendly wrappers around the raw power of LLAMA.cpp. They package up the exact process we are about to do. By learning this yourself, you are learning the source. You get full control. You can quantize any model, not just the ones in the library. Okay, let's get our hands dirty. It's a two-step process. First, we get the model. Second, we quantize it. Okay, for this purpose, I am taking the Quen 3 4 billion model. It is up to 8 GB. This is the notebook I worked with. Okay, firstly, I cloned the repository, LLAMA.cpp repository. Then I go to the folder. Now I build it. It usually just one command. If you go to the docs, it will show you very clearly. Wait, I'll show you. Yeah, here you can see there are so many supported backends. You can choose whatever you want upon your interest. Basically, if you have a NVIDIA GPU, you can go for the CUDA thing, or if you don't have any GPU thing, you can run this in a CPU. Okay, we don't have any GPU, right? So we can take the CPU commands from the, yeah, here is the CPU build. These are the two commands to complete the build process. Okay. After the build process is completed, first we use a Python script inside the LLAMA.cpp folder to convert the Hugging Face format into a gguf file. This is the format LLAMA.cpp uses. Uh, in the LLAMA.cpp files, wait, I'll show you. In the LLAMA.cpp files, we have this thing called convert hf to gguf.py. This is the file which converts the Hugging Face models into LLAMA.cpp, or what we say .gguf format, which we can run in a local computer. Okay. Okay, first I downloaded the Quen 4 billion parameter model from the Hugging Face itself. So I stored in original model folder. So here you can see I downloaded the original model from the Hugging Face hub. You can see here. Now to save the quantized model, I created a repository named quantized model. Now here you can see, after build process, there are some files gonna create in a build section. In the bin folder, there is a bin folder. In the bin folder there are tools, something like llama-quantize, llama.server, like that. By using llama.quantize, we quantize the downloaded model in the format of Q4KM, which means 4-bit quantization. Okay, after completing the quantization all itself, we created a repository, and I pushed into the Hugging Face. Okay, here you can see I uploaded two models. Here you can see the original model consists of 8.6 GB and contains lot of files. After the quantization, it's just a single file which is only 2.5 GB. Okay, here you can see the massive difference in a storage. Okay, and I also quantized the Gemma 2 billion parameter model. It's literally a 1.63 GB file, which already hits 111 downloads. Okay, I uploaded it yesterday. Now I will show you how these models will work. Okay, this is the, okay, I'll upload this notebook in a GitHub. You can check it out later. I'm running this cell by consuming the Gemma model. Okay, it's running. Okay, it's just a gradient interface. Wait, it will take some time. Okay, we are here. Okay, I'm sending. Okay, I'm sending hi. See, there is a response from the quantized model. Hello, it's great to hear from you. Okay, okay, I'm asking a simple question here again. See, the capital of India is New Delhi. It replied like a normal chat GPT. We can see it is a quantized model. Okay, now I'm showing you this in a collab online environment. So you get a question. Anand, you said it's gonna run in a local computer and with no internet and no fees. Yeah, yeah, I will show you this thing. Now we are going to do this in a local computer with no internet. Okay, for this we need to follow the same steps I did in this notebook. First we need to clone the repository. I already did, so I'll go to that. Okay, this is the LLAMA.cpp folder. As I told you, after the build process is completed, it gets created a build folder. In that build folder we have a bin. In the bin folder you'll see all these tools offered by LLAMA.cpp. Okay, now I'm running the Gemma model, which I have already downloaded from the collab itself. So as you can see, this is the model q4km.ggf. So I'm running this locally now. Okay, now here you can see dash m means the model. My model is located in a slash downloads folder itself in my local computer, and dash ngl means number of GPU layers. So we are not going to use the GPU, right? So we are going to run this in a proper CPU. Okay, so if we put any number, those many layers are allocated to GPU and the remaining ones are in a CPU. So we are not going to use GPU, right? So I put 0. So I'm hitting enter. So as you can see, the prompt pops up. So I'm sending hi. So it responded, hello, it's a great to hear from you. Okay, I'm asking the question again as I asked earlier. What is the capital of India? As you can see, the capital of India is Delhi. Yeah, it's responding like normal chat GPT. Okay, okay. So this will run in a offline too. For this, I'm turning off my hotspot, so there is no internet connection. You can see if I search something. Uh, yeah, you can see there is no internet connection to my laptop. Now I'm going to run the same command again. Okay, I'm sending hi again. You can see. So if you want a graphical user interface version, that means GUI version, so there is a tool in the llama cpp itself. It's a llama server. It also serves like a open API endpoint, so I'll show you that also. For that we use the same command as before. In the place of llama-cli we put llama-server. Okay, for the server we mention the model where it is located and the number of GPU layers, which is 0, and I'm mentioning the port here, port which is 8000. Okay, I'm hitting enter. Okay, as you can see, the server is listening on HTTP. Yeah, it's a local host and listening in a 8000 port. I'm going to the port. Okay, you can see it is like a chat GPT interface. I'm sending hi. See, the results are coming very fast. So it even can generate code as well. I'll ask this a simple Python code. Just see. See, it's running Python code with proper indentation and docstring as well. This is like a normal chat GPT. As you can see, I don't have any internet connection at all. Yeah, it's giving a small little note also with time complexity, which is often okay. Okay, this is the GUI format. See how simple it is. I already opened a tab previously when I have internet connection. This blog shows, actually this website shows how we can convert the LLAMA.cpp models into a OpenAI compatible web server. Okay, in place of base URL we just replace the URL that it's running. Okay, in our case it's running on a local host port number 8000. So we just need to make a configuration file like this, host and port with the models. Yeah, this is the ngpu layers I told you earlier, which is ngl. Okay, I'll show you that also. As you can see, this is running in a where it is running, it's running in a 8000 port number, which is localhost 127.0.0.1. Okay, this is what I told you. We can configure like this. If we follow all the instruction mentioned here, uh, we can simply convert our models into a usable API format. Okay, now I'm gonna show you this. So I'm commenting some code here. I just wanna list out some models available in our computer, which is only a single model running itself in a localhost 8000 port. So I'm running uv run test.py. This is the command. Hitting enter. As you can see, uh, it connected to the server and found a model which is q4km. Okay, now I'm undoing the previous command, which you are already familiar with OpenAI endpoint. We just replaced here a small thing that is a base URL, which is our LLAMA.cpp is running virtually. Okay, you can see we just replaced the base URL here with the URL given by the LLAMA.cpp. Okay, and the API keys, whatever you want, you can type anything. Now I'm asking this a question: what is name? Okay, I'm running this again. Okay, so as you can see, I don't have a name in the same way a human does. I'm an AI chatbot designed to assist you with various tasks and provide information. Okay, see how simple it is. We take a model from Hugging Face and quantized it, and we even run the large model in our computer CPU itself. Okay, we even fine tune the model we want and quantize it to, and we can run, which is compatible with OpenAI endpoint. So if you want to generate a structured outputs, we can do that also by using pydantic and typing modules. We can do that as well. I'm typing some code here. As you all familiar with how to generate structured outputs from OpenAI models. If you don't know, I'll quickly show you that. Now I'm defining a class uh, which is data, which is inheriting from base model, which consists of name. It's a string. By giving this field, so we can write the description here. Description. So name of the fruit or okay, and next calories, which is the string again. Fruit on vegetable. So you want to make the model respond with a JSON object that gives you a list of fruits or vegetables with their calories. Okay. Mm, output is I'm inheriting this model itself. So in this I'm telling data, which is a list of data. Okay, data we defined here, data class. Okay, now in here instead of create we use parse, and also which is and also we define a parameter here which is response format. So we need to respond this model with this output format. Okay, I'm mentioning here with output. So instead of message dot content also we use here parsed. Okay, now I'm running this. I'm asking the question, can you give me 10 fruits or veg veg 10 fruits or vegetables with their names and calories. Okay, this is the prompt I'm giving to the LLM we downloaded. So I'm clearing the screen. I'm running the file again. As you can see, it's running. As you can see, uh, the response comes in a structured format we defined. See, it's a list of data objects, contains name and calories, name apple calories, and again banana calories, and again orange calories. Okay, this shows how we can get structured outputs from the models. Okay, so this is the demonstration of quantization and the power of quantization. If you found this valuable, follow me for more practical AI and developer tips. Let me know you in the comments what model are you going to try run locally first. Thank you.